Welcome back, ladies and gentlemen. Today is Wednesday, February the 17th, already screwed up. And today's lesson is on adding and subtracting rational expressions. And again, if you look at the handout that I've given to you, ladies and gentlemen, it's the package that has, I think, 4 pages to it. There's some instructions there that I think you can read on your own. We're going to actually just take a look at example 2 right now. We're going to skip example 1. Example 1 is just dealing with equivalent fractions. I think you can try to figure it out yourself. So if you do want to message me later, you can. But let's take a look at example 2a. And what we have to do is add these fractions together and simplify and state the restrictions if possible. So let's just go through the steps one more time. The rules are: factor everything if possible first. 2, state restrictions. And 3, simplify. The big idea with adding and subtracting fractions is an equivalent denominator. Oh gosh. I'm choking already. It's been a long morning. And how do we do that? It's pretty easy for these first examples. So in this question, 2x over 3 plus 5x over 7. Notice the answer is not 7x over 10. If you thought it was 7x over 10, I'm sorry, that's not how we add fractions. So what a lot of students do, and this is a teaching purpose, a lot of students say the lowest common multiple is actually the product of the two. What is the product of this case? 21. One more time, it is not always just those two numbers, and you'll see hopefully in the future example, I don't think there's any of these examples, what I'm trying to do. This hopefully will guide you. That's how I like teaching my students, this method, rather than just kind of figuring things out. Now, how do we do that? A lot of you realize I'm just simply multiplying by 1 to the first fraction and multiplying by 3 over 3, or 1 to the second fraction. So when we do that, and again, notice I should have actually followed my steps. We actually factor first, then we state restrictions. There are actually no restrictions here, because that's a 3 and that's a 7. So the lowest common multiple is 21, and a lot of you realize we get 14x plus 15x. And that's the intermediate step. What's our final answer? Notice now, we simply add or subtract numerators. So in this case, 14x plus 15x, 29x over 21. However, for adding and subtracting rational expressions, you have to be careful. Sometimes there's more simplification. And I don't think it's going to pop up in these 5 examples. I'm not too sure. You got to remember, I actually don't memorize these answers. I'm actually always doing this to make it live. Any questions from the class here about question A? Questions? So let's take a look at question B. In the question B, it says 3 over 2x plus 7 over 5x. So again, the idea to teach it, first of all, factor first, nothing to factor. State restrictions. I think there's only one restriction. X cannot equal to, I think the whole class agrees, 0, right? Because 0 make that 3 over 0 you can't have, and 7 over 0 you can't have, right? So that's the restrictions. So what is the lowest common multiple in this example? Lowest common multiple in this case? Again, 2x and 5x. Notice again one more time, in this case, it's not just the product of the two. The coefficients, I think everyone agrees, is 10. Because this one is missing a 5, and this one's missing a 2. But notice, the lowest common multiple is not 10x squared, just 10x. Why? Because this has an x here. This has an x. Allow me to illustrate this further. This is why, hopefully you're looking at the 2 examples. In this example, it was clearly the product of the 2 denominators, 3 and 7. In this case, what I'm going to multiply this, in order to get from 2x to 10x, all I need is a 5 over 5. And what I needed for this one, I needed 2 over 2. So when we multiply those out to those fractions, And that's why I actually, when I teach fractions in grade 9, I actually like it this way. I don't like having multiple denominators. It's just easier, right? So that my focus is to add subtract as the numerators. That I get in the denominator 2x times 5, that's 10x. And that's the same for this. 5x times 2 is 10x. Before we continue, everyone okay with that lowest common multiple? Notice it's not 10x squared. 10x squared will work, but then we have to simplify. So you might as well simplify or reduce already. So what do we get in the numerator? 15 plus 14. So it's almost identical, not quite to that question. And then now you simply add and subtract numerators, you get 29 over 10x. And that's the answer with that restriction. So the hard part, honestly, of these units, and maybe example 1 is actually good, is to get that lowest common multiple. Can I get a volunteer from the class for question C? Obviously, we factor first, there's nothing to factor. State restrictions, I think I would agree there's no restrictions. Can I get a volunteer for someone from the class for question C? What is the lowest common multiple for 2x minus 3 over 4 plus 6x minus 1 over 3? Any volunteer? What's the lowest common multiple? Tom?
12.
It is 12. Right? So again, one more time. I like doing this. It just guides me what I'm going to do. And there's a reason. These questions I think are a little too easy, but their foundations will help you when we get the harder questions. And again, if you look in your textbook, and it escapes you right now what section it is definitely in chapter 2. It's probably section 2.6 or 2.7, I think. But anyways. In order to get to 12, we need to multiply this by 3. So watch what I'm going to do, just to show my work one more time. This time I'm actually going to do this one slowly. That's 3 times this 2x minus 3. Notice I'm copying the plus sign. So that's a plus sign there. Hopefully I'm slow enough for you, ladies and gentlemen. 4 times that 6x minus 1. So I definitely need some more room. So maybe I'll erase question E if that's okay. And that's okay. And so notice, before we can add those numerators together, I think a lot of you understand the skill set. You have to probably expand, right? That's why, one more time, this is a little tricky. When we talk about these rules of simplification here, simplifying doesn't always just mean, dividing out or anything, or, reducing. Sometimes it also requires expanding. So 3 times 2x, that's 6x. 3 times negative 3, that's negative 9. Plus 4 times 6x, that's 24x. Minus 4, all over 12. Now we're not done yet, but everyone okay with my intermediate step? Some students actually don't do this step, they go directly to here, which is fine too. I just want to warn you, I recommend for some of the easier questions, or when you start doing your homework, just go slow and go careful. Try to figure things out. Hopefully I didn't make mistakes. Can someone just double check I did that right? Thank you very much, Abby. So then now, we collect like terms. 6x and 24x, that's 30x. Not negative 9, negative 4 is negative 13 over 12. Then, in yellow, sometimes there's more simplification. Just to talk about really quickly, this is the answer, I think, 30x minus 13 over 12. But let's pretend this was the answer that we got. This is again not the answer. Ladies and gentlemen, if you're watching from home, let's just say we got this as an answer. So let's say we got 30x minus 12 over 12. This is safe. This is not the answer. And again, if you're not copying this down, that's fine. Notice, in this case, once we've collected like terms, we should maybe take out a GCF for the numerator, because it's actually factorable. What number goes into 30 and 12 nicely? I think everyone agrees 6 goes into them nicely. So 6 is 5x minus 2 over 12. And notice what I'm trying to share with you, ladies and gentlemen. This is not the answer. And again, if it's going off screen, I don't care. Sorry for people at home watching this. 6 goes to 6 once, 6 goes to 12 twice. And so our final answer would have been 5x minus 2 over 2. And I'm just trying to show you, this is why adding and subtracting is harder. Again, if I'm off screen, I don't care. That's why you have to be careful with this. Sometimes there's more simplification. So that rule here is part of this 3-step process. Let's just pause the class here for a second. Any questions from our live class? What I wrote here? Eden.
Where is 12 in like the red thing?
In this one?
No, not the new one. Like the wrong one.
Oh, the wrong one?
Where did 12 go?
This?
The top.
This one?
newer.
Oh, I factored out a 6.
Oh.
Sorry, what I'm doing, I'm looking at the 30x minus 12. When you collect like terms, with adding, subtracting, sometimes it will, you can't see it here. That's why I recommend you go slowly. And then when you collect the like terms, and that's why I just said, maybe you got 30x minus 12. And this is a 12 too.
Okay.
So, oh my gosh, they're all even. But you should look, don't just take out a 2.
Oh, so you found a GC.
So I took a GCF out of the numerator, which is, again, I just made this up on the spot. I'm not that good. I'm pretty good, but not that good. I just managed to make it 6. And 6 and 12. Hey, wow. But we couldn't have done that initially. You can't see it. So that's what I'm just trying to show you. And again, that might not always pop up. It might not always pop up. Okay. Any questions still? Nice. It's okay. So we're getting question D. I don't like this question, but say let me. Unfortunately, I do like keeping things on the chalkboard, but because now it's becoming harder and I'm going to have to erase some stuff. So if you're at home watching this, you can pause the video. Unfortunately, I'm not going to pause the video. I have to unfortunately erase some of this. Anyone still need it in class? A or B? Is that okay? I'm going to erase this. I just need more room. There's just not. So let's just recopy question D. So what do we got? 4 over 3 minus x. And these seem to be all addition questions, but the hard part is actually subtraction. Okay. So we're supposed to factor first. State restrictions, I think everyone agrees that both of these are the same. X cannot equal to 3. Okay. However, something seems suspicious before we start adding. What's the lowest common multiple? Now, a good argument is saying, Mr. Chen, these aren't alike, so why don't I just take the 2 products? And you can do that way. But there seems to be suspicious about this fraction. Remember, see that? Like, this is x minus 3, which again, this is not a big deal, this one here. 3 over x minus 3. It's this one, right? Ugh. So I think, like, I actually don't know the answer to this. If I factor in a negative 1, what am I going to get? I'm going to get negative 3 plus x. Everyone agree? But then that's why a lot of you, if you've seen the video last night, that's why these ones tend to be harder, and that's why there has to be some kind of trick. Actually, this negative 3 plus x is commutative. Now adding is reversible, so I can actually change that to x minus 3. Everyone see that? With a negative 1. Everyone see that? And again, from grade 9, just to show you what you've been taught, a negative 1 over 2 is the same thing as 1 over negative 2, which is, of course, a negative fraction. I think everyone agrees they've learned from grade 9. And notice my negative here. I actually don't like negatives in the denominator. So watch what I'm going to do. I'm going to put this negative up here. So I know it seems like a dumb question, but can someone from the class tell me now, what's the lowest common multiple? You know, it seems like a trick question. It's not a trick question. It's just obvious. Anyone want to try to say it in class? Oh, Kai?
X minus 3.
It is just x minus. We didn't have to do anything, Mr. Chen. See, notice it looked like I was going to take the product of 2, but Mr. Chen, they don't look alike, right? So question D of this example was tricky, right? And it's okay, some of you might still need to look it over again and again, but slowly you realize this question is really, I'll just rewrite this, negative 4 plus 3 over x minus 3. Now some of you don't do this, right? Like, some of you will just work from here, but I'm just trying to show you, our classmate said, Kai said that the lowest common multiple is x minus 3. So we didn't have to do anything. Right? Everyone agree? So then now, even though it's an addition question, it's actually a subtraction question. Final answer, and this is about math, it's actually negative 1 over x minus 3. And that is the answer with that restriction. Hopefully the camera got that. And again, if you're at home, ladies and gentlemen, you might have to pinch Or zoom in, maybe I should. This, I don't know, it should be working. Hopefully it's not muted. Any questions so far? Before we get to question E, and I'll pause the video, or I'll pause the recording. Any questions left from the students in class? So there's no lowest, lowest common multiple, we didn't have to really worry about. So, example E, bless you. Copy it out. 5x minus 2 over 5 minus 2x plus 7 over 3. Factor first, we're done. State restrictions, there's no restrictions because that's a 5, that's a 3. Simplify, well, I would recommend you do it this way. Lowest common multiple is the product of the two. In this case, it's 15, everyone agree? So I think everyone knows what I'm going to do. I'm going to take that first fraction, that 5x minus 2. I'm going to multiply it by 3. Watch what I'm doing carefully, ladies and gentlemen, in orange. I'm going to put that minus sign there. There's a reason why I'm going slowly and intentionally in with colors. Subtraction is hard. This is, we have to multiply this by 5. So put that 5 there. Times 2x plus 7. However, I do recommend, if you're going to do it this way, you might want to introduce some square brackets. There's a reason why a lot of students get this wrong. They don't get the first part wrong. Clearly, we're getting it negative 10x. A lot of you get that right. It's unfortunate the next part that most students think, when you multiply this by 5, you do get 35, which is correct. It is going to be 35. But we're going to be subtracting it eventually. So I do recommend, and again, this is just me, how I was taught, so I'm trying to pass that on to you, ladies and gentlemen, is how you can group and be careful with subtraction. With addition, there's no problem, because addition is commutative. It's subtraction that is always a little tricky. And so, first of all, I'm going to show you the correct way, and then I'll show you what a lot of students might make a mistake at. So a lot of you know, as soon as we want to finish this off, we got to expand, so we get 15x minus 6. This is never the problem part, this part. Most students actually get this expression right. Notice what I'm trying to do is just in that subtraction sign. I'll put some brackets here. Distributed property, 5 times 2x, that's 10x. 5 times 7, that's 35. But notice again one more time, when you multiply this fraction by 5 over 5 and this one by 3 over 3, we are subtracting not just this, but subtracting this whole expression. And so that's why I recommend that you go this slowly. And so our answer again is bad math here. Hopefully the screen is going to get it. We get 15x minus 6 minus 10x minus 35. And again, if you're listening to me, ladies and gentlemen, I said most of you get this right. The common error is this. They forget that it's negative 35, or it's subtracting 35. Let's just pause here. Any questions so far? Again, most of you will put, a lot of students unfortunately make that mistake, they put plus 35. And it is 35. But we're subtracting it from them. Rita, you have a quick question?
So even though like there's a plus in the first part, because of subtraction, the entire thing has to be subtraction.
That is correct. When you subtract, again, because even though our Board of Operations says we have to do multiplication first, right? So that's what I am distributing. That's why I'm rewriting it this way. I'm showing the 5 there. But that's why I recommend and that's why, ladies and gentlemen, you see subtraction, especially with fractions or rational numbers, you be careful. You go slowly. You're subtracting this whole thing when you multiply by 5. And I'm just trying to point out what a lot of students, that's why in grade 9 when you were doing a lot of your, when you were trying to solve equations, it was always the subtraction questions that you got kind of wrong. Right? So for example, like, again, I'll do this off screen so people don't have to see it. But questions like this, something like this, when you solve this, a lot of students get this portion wrong or something. can't think of it. When you had to solve stuff like this, like, it's hard because of the subtraction. Anyways, we're not finished. 15x minus 10x, that's 5x. Negative 6 minus 35 is negative 41 over 15. And I think this is the answer because this is a prime number. Let's just stop recording.